Hey, what's going on? We're having two sequences right here, and we will need to find the limit of the sequences, and of course, in their convergences. We're gonna start with the first one by finding the limit here. So it's kind of a proving that they are converging. Okay, we're having the limit of wrong thing. Okay, we're having here the limit when as n approaches infinity of 3n to the power 2 minus 1 over 10n plus 5n to the power of 2. Okay, when you have to do with a limit or a sequence or something like that in this form, the only thing to do here is to factor the largest power of n, so you can cancel and then take the limit. So it goes like this. The limit n tends to the infinity n tends to the infinity. The largest factor of n here is n to the power 2 times 3 minus 1 over n to the power 2. The whole thing over n to the power 2 right here times 10 over n plus 5. Alright, and as you can notice, when we have 1, when n tends to the infinity, the denominator here tends to the infinity and the whole thing tends to 0. Okay, and it is the same thing with this one here, and then we can cancel out the n to the 2 and we still have our result will be therefore. So we're going to say the limit when n tends to the infinity of the function we have n equals to 3/5. That's what we have, 3/5. Okay, here we can say that our sequence converges. The sequence converges and its limit, just put a comma and write it, limit converges and the limit is 3/5. Now let us see the second example. In the second example, it's a little bit complicated. Even if you take the L'Hopital rules here, it's a little bit tricky. So you got to be to have some rules, some theorem that really to do that. We know that by a theorem, mathematically, that if you have a limit when n approaches to infinity of an absolute value of n, which tends or which is equal to 0, then the limit when n approaches 0 infinity of an would also be equal to 0. All right, so this is what we're going to do here. So we're going to say the limit when n approaches the infinity of the absolute value. This is the absolute value bar of minus 1, 1. I may put a parenthesis here to the n divided by n, right? If you put it in absolute value, of course it's going to be, because the absolute value is going to take this minus away. The absolute value is always to say that the value is going to be absolute, going to be positive, and no, it's not going to be negative. That's what I'm trying to say. So the absolute value will turn this negative to positive. So we will have, and 1 to the power of n still be 1. So therefore we will have the limit n approaches the infinity of 1 over n, and the limit here is, of course, like what we've seen before, is 0. Right? So we can say then or therefore the limit of when n as n approaches the infinity of -1, oh sorry, it's not a big one like that, of -1 to the power of n over n equals to 0. And we can say that the sequence converges also to a value of 0. Let me just put sequence converges, and then 0 here, of course, converges to 0. Converges to 0. Okay, the sequence converges to 0, and this is our result for these both exercises. Alright. So again, for these two exercises here, just put 1 here and 2 there. Okay. For the first one, you get to to factor the largest power of n and then take the derivative. It's gonna be easy. And for the second one, you just use the absolute value, which kind of take the minus sign away. I mean, turn the whole term to a positive term, so you can take its limit. And once you take limit, so according to this theorem right here, you can also say therefore this sequence here is also tending to 0. I mean, its limit is 0, and then you can conclude by saying that the sequence converges to 0. Alright, so thank you for watching again. Until next time, bye bye.